ಎಷ್ಟನೇ ಪೇಜ್ ಬರ್ Good afternoon. Am I audible?
Yes, sir, you are audible.
Yes, sir.
Yes, you are audible. I'm audible. You? Please say my screen. Is it visible? I have shared my screen. Can you please? So let me start. Okay, so good afternoon to everybody. First of all, I would like to thank the Krishnamurthy principal of the Citadel College of Arts, Science and Commerce and organizers of this activity, Dr. B. Norapal Jyotiraj, for inviting me to the talk. And I'm very happy to be delighted to be a part of this space national activity and research methodology for experimental and theoretical sciences organized by this Siddharanga College of Arts and Science Commerce. See, as you see the title of FDP, National FDP on Research Methodology for Experimental and Theoretical Science. My talk is related to the theoretical science because I have a background of theoretical science. So let me start. The title of today's talk is a question. What is mathematical research? Can anyone please share your thoughts on what is mathematical research? So there are 83 participants are there. I don't know how many are from mathematics background. Can you please reply to this, everybody? So this is for only for mathematics participants or it's spreading all after the science? Huh? Oh. So okay, so let me start. Okay, so mathematics is often seen as a philosophy full of formulas, theorems, and definitions. But in reality, mathematics is a living subject. So new ideas are discovering every year. This process of discovering is what we call mathematical research. So here is my overview of my presentation. Here is my overview of presentation. First, I will begin with the nature of mathematics itself. What maths makes unique among other sciences. Then we will look at what counts as mathematical research and what does not. Then research process stage by stage, and I'm going to discuss on research styles, methods, and finally I will share some resources and important funding opportunities available for researchers in India. Let me begin with the fundamental question: what makes mathematics different from other sciences? Think about it. Would anyone like to answer about this question? What makes mathematics different from other sciences?
It has strong logical foundation, sir.
It has strong logical foundation. Okay, next. Anyone? You just experimental things and theoretical. You can do the answer. Any other? Okay. Think about physics, chemistry, or biology. In those fields, knowledge is built through experimentation, correct? And observation. Scientists perform experiments. They take measurements and they test their results again and again, and then they will build it. And sometimes, even after 200 years, a better explanation may come. That's how experimental science progresses through evidence, through reasons. But mathematics operates in fundamentally different. Mathematical truth is established through rigorous proof, not through experiment, not through measurements, not through repeated observation, but through logical deduction from clearly stated assumptions step by step. So mathematics studies patterns, structures, and logical truths. And all these truths are independent of the physical world around us. So these four characteristics makes mathematics unique from other sciences. Mathematics offers absolute certainty through rigorous proof. It builds cumulative knowledge. Every theorem at any time proved remain valid. Correct? And later generation build on top. It is universal and timeless. The Pythagoras theorem was just as true in ancient Greece as it is today. And around 2300 years ago, Euclid proved that there are infinitely many prime numbers. Still, that theorem is true and in future also exists. So, and it is deeply abstract. That form a foundation of modern science, engineering, technology, and economics, and today even emerging fields like artificial intelligence, data science, machine learning, mathematics is must be required. So when we talk about research in mathematics, we are not just solving problems. We are not just filling pages with symbols. We are adding something permanent to the human knowledge, something that will be permanently in the literature long after all of us are gone. So now there is a one philosophical question. There is a one philosophical question: is mathematics discovered or it is invented? For more than 2000 years, since the time of Plato, philosophers and mathematicians have debated on this question. According to the Platonism, mathematical truth already exists independently of us. They exist whether or not human belongs to here or not. Numbers exist already, and the value of pi and d exist before they are discovered. Pythagoras theorem exists before Pythagoras discovered it. So whatever mathematics is there nowadays, all are exist, but mathematicians are discovering that. So in view of this, mathematicians are like the explorers. Just as explorers discover new land, mathematicians discover hidden truths of mathematical universe. There is another way. Formalism. According to this, mathematics is a human creation. No. Unmute someone, please mute. Hello? There is a disturbance. Sorry for it. Okay. So according to this formalism, mathematics is a human creation. We choose axioms, we define structure, we create symbols and rules, and from those rules we are discovering new results. So in this sense, mathematics is something we build. It is like creating a game. First we define rules, then you explore what follows from those things. Mathematics is like an artist, creating a new things within the framework of rules and creativity. So now in real mathematical research, both of these perspectives play important role. Mathematical research combines discovery and innovation. We first discover patterns and ideas through intuition, and then invent precise proof to logically establish it. So research exists in the space between discovery and invention. So now let me ask more direct question: what is the research?
ರಾಜೋತ್ಸವದ ಈ ವರ್ಷಕ್ಕೆ ಬೇಕಂತವ್ರಿ ರಿಪೋರ್ಟ್ ನಿಮ್ ಕಲ್ಚರಲ್ ಅಂಡ್ ಕನ್ನಡ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಶೇರ್ ಮಾಡಿ.
Hello, Itiraj.
Hello.
Hello. There is a disturbance. The participants. Yeah, because it is okay. So what is research? Anyone? Any thoughts from the participant? What is research? You take not irrespective of the mathematics. It's not about the mathematics. You take anything. What is research? General.
Observing some gaps between already found results
Okay.
and trying to fill up that.
Okay. Any other? Okay. Here are the I have taken a few things directly from the available source. According to the Oxford Online Dictionary, it says that research is the systematic investigation into the study of materials and sources, establish the facts, and reach new conclusions. And there is another one. Wikipedia says that research can be defined as the search for knowledge, or as any systematic investigation with an open mind to establish novel facts using a scientific method. So most of the inspiring things is that the research is rarely done in isolation. Most progress in mathematics comes through collaboration, discussion, and building on the work of previous work. There are few exceptions are there, like take for example Ramanujan. Ramanujan worked in isolation without the formal training in mathematics. He worked and he gave around 3,000 results in mathematics without the formal training in mathematics. And if you see the past mathematicians, the great mathematicians, they all worked in isolation. But modern mathematics is not like that. Modern mathematics must be required collaboration, discussion, and you must have to follow the previous one. Yeah. So that's why this one, the Isaac Newton, one of the greatest scientific mind in history, said that if I have seen further, it is by standing on the shoulders of giants. In mathematics, this is literally true. Every proof we write brings on definitions, lemmas, and theorems that others have established before you. In 2017, Stephen Hawking said that each generation stands on the shoulders of those who have gone before them. Just as I did as a young PhD student in Cambridge, inspired by the work of Isaac Newton, Maxwell, and Einstein. So that's why literature's review is the way foundation of research. Before you can contribute something new, you must know deeply what already exists. This brings us to the question that what has already been done in mathematics. Today's mathematics is a vast and beautiful diversity with many deeply interconnected areas. How mathematics is organized, modern mathematics. To help to organize this enormous body of knowledge, mathematicians are using this mathematics subject classification. This is the current version is 2020, MSc 2020. This classification is maintained by American Mathematical Society and JP Math Open. This classification also helps researchers, especially those just started out the research, to identify their own area of interest. And you can see that this classification system was first developed in 1940 and has been updated roughly every decade since from 1940. And the current version is MNC 2020 subject classification. If you see the difference between the MHC 2010 and MSc 2020 classification, new codes were introduced for data science and machine learning. This shows that how mathematics is growing in these areas. And the coverage of mathematical physics was expanded, combinatorics and topology were redefined, and new codes were added for network science. This tells us something that mathematics is living, evolving discipline. It is not finished. So let me share all major areas, research areas in mathematics. Each area is again subdivided into sub areas. So let me share all major areas in mathematics. So these are the things. You can see that combinatory sort of theory, general algebraic system, and number theory. This is the way I'm working. And this number theory again divided into several sub areas. Where in that I'm contributing to the some theory of potential, special function, Q series, continued fractions, and many other things. These are the main research areas of mathematics. People are working on these areas. And maybe, of course, your interest also may fit in any one of these. You can see that. Probability, statistics, numerical analysis, computer science. Okay, so now the question is that what you think about mathematical research? Is what you think mathematical research leads to? Anyone? Now the question is that so what you think about what mathematical research leads? What mathematicians are doing in mathematics? What discovery they are doing? What research they are doing?
It's mostly like development of theories
Development of
their-
theories. Okay,
and their applications.
their applications. Okay. Any other? See, mathematical research is not about to developing, not exactly about developing theories or something. There are many ways to contribute many things. Okay. Uh, this is the most classical is proving new theorems, establishing mathematical truths that were previously unknown. Another type is solving open problems, answering questions that the mathematical community are trying to prove those questions. Third is finding counterexamples. And you can also generalize the existing results. That's also a mathematical research. Take a theorem that works in a special case and extend it to the broader sense. Or you can simplify the proofs. Find a more elegant and more transparent argument for something that was previously proved in a complicated way. You know that Pythagoras theorem, it is proven around 3,500 years ago. Now we have around 270 proofs are available for Pythagoras theorem. All proofs are proving it different. That is also one kind of research. Take existing result, we have to prove them in a different way. That idea must be new. That is also one kind of research. And behind these, we can develop new methods. So create techniques that can be used to tackle certain kind of problems. You can create a new framework. So introduce your own definition and structure that opens new mathematics. You can connect different areas. You can classify the results. And finally, you can use computational software to generate computer assisted and algorithms. And all these counts genuine mathematical research. The key requirement is that the result must be new, correct, and non-free. That is a very important. And let me say some examples. This is one of the famous example in the history of mathematics. It's called Fermat's last theorem. In 1637, the French mathematician Fermat wrote in the margin of his copy of the book about this problem. So no three positive integers a, b, c satisfies the equation a to the power of n plus b to the power of n equal to c to the. for any integer value n greater than. For n is equal to 1, we have a solution. For n is equal to 2, we have a solution. But when n greater than or equal to 3, this equation has no three positive integers. No three positive integers satisfy this equation. And the Fermat claimed that he had a proof, but he did not record this. The generation after generation of brilliant mathematicians tried to prove this theorem. It becomes the most famous unsolved problem in that. But in 1995, Andrews Weil, after years of secret and intense work, published a complete, and his proof required development of substantial human mathematics, like the theory of electric curves, modular theorem, deep connection between number theory and different. What is a key lesson is that a good problem, it's all good research problems. You need to connect different areas of mathematics. So there is another one. It's called four-color theorem. This four-color theorem says that a map can be colored using at most 4 colors, such that no two adjacent regions have the same color. In 1852, Francis Guthrie conjectured this one, and in 1976, Apple and Hankel finally proved it, but their proof shocked the mathematical community. Why? Because their proof requires computer to check nearly 2,000 cases. A human cannot read that 2,000 cases. You cannot do by hand. This sparked a major philosophical debate whether is a mathematically computer-assisted tool really mathematics or not. Can you trust something that no one can read? This controversy has never fully resolved, but it did lead to a new acceptance. Computation is now legitimate and valued in mathematical research. So today, computational mathematics is a driving field. So what is not research? Now let us go to the what is not research. So you know that there are many valuable mathematics activities that are not research. See, solving textbook problems is no matter how difficult, it's not a research. Because the answer is already we know. Applying known techniques to the standard problem is not a research. Summarizing what others have done is not a research. And discovering the known results that are already there in the literature is not research, provided you that idea how you obtain those existing results. If your idea is new, then you may consider as a research. But these activities are not worthless. These are all, in fact, essential. Think of these activities as a training. By doing these activities, you will learn more things. You will learn you gain more knowledge on your research problems. So now let us see how mathematical research actually unfolds. So I have mapped it out as a 9 stages. The process begins with problem identification. Then you conduct a background study. Then comes to the exploration and experimentation. From that, you form a conjecture. And you then work on proof development. Once you have a proof, you verify it carefully. Then you write it up. Then you submit it to the journal. And finally, we disseminate the work to the broader community. So let me say something here. This process is not linear. By following these steps, you will get many setbacks, you will get many failures. So let me take one by one. The question is that where to identify research problems. The first stage is identifying the research problem. Not every question is a good research problem. So how can you say that a problem is a good research problem? A good problem, a good research problem should be clearly formulated, genuinely open, and there is a reasonable chance of making progress on the problem. Then only we say that that problem is a good research problem. Where do you get this research from? That is a question. So the answer is that you already know that the richest source is that reading recent research papers. If you take any research papers, good research papers, so the authors always mention open questions and possible generalizations in their conclusions. These are the direct invitation to the others to work on those problems. You can also find problems in classical problem collections by attending seminar, conference, or by having conversation with colleagues and speakers, or simply by asking yourself. You take your theorem or one result, you ask your own questions like that. You take any statement, that statement have some condition. What happens if you relax those conditions? Or you take a theorem, can I generalize this theorem? So such kind of simple questions, you ask yourself, you can find a research problem. One richest source is that reading a recent research papers. And you have to read the conclusion sections in that paper. In that conclusion sections, the authors, they have given what they have done, what they are unable to do. They said they are going to say everything clearly in that conclusion section. From that, directly you can get the research. So after getting research problem, once you have identified a problem, research problem, the next step is that immerse yourself in that existing literature. This stage is very, very important. You need to read the original papers that first that concept is introduced. You need to read related results, survey the articles, and these broader points. And fundamental textbooks you have to read that build the techniques you need. From this study, we know that what techniques are standard in the area, what notations are conventional, what approaches have been applied, and how they succeeded, whether how they failed, and what are the sub-problems remain open in that area. So after that, this stage is not about doing anything else. It is about developing a team for the problem. So in this stage, you are going to study examples, test your ideas, look for the pattern, and see what happens in the particular cases. Sometimes if you find a pattern, sometimes the patterns you observe in small cases often suggest what is the general theorem should say. And sometimes even suggest how to prove it. After this, this is a conjecture formation. After enough exploration, you begin to form a conjecture. A conjecture is a statement you believe is true, but not yet true. You believe that the statement is true, but not true. In mathematics, you cannot accept a statement is true directly. You need a proof of that. You have to prove step by step. So let me give you beautiful examples here. Take this is a one. There are infinitely primes. Of course, 3, 2, 3, 5, 7, 11, 13, so on. Whether there are infinitely primes, that is the question. Yes, this question is not conjecture because it is proved by Euclid. In 2300 years ago, Euclid proved that there are infinitely prime numbers. When the statement is proved, it is not a conjecture, it becomes theorem. So let me I have collected few statements, especially number 2. So like that, you can find out conjectures in all the areas of mathematics. So just I have focused on only number 3. So let me take this one. Let me take this. So if P and P plus 2 are primes, then they are called as a twin primes. The first few twin primes are listed on the slide. You can see that. Now the question arises that whether there are infinitely twin primes. It's similar to the previous. There are infinitely primes. Same question if you ask for these twin primes, whether there are infinitely twin primes. There is a question. Very simple one. Just asking yourself, whether there are infinitely twin primes. This is an unsolved problem. This is called a twin prime conjecture. Despite enormous computational evidences, still we don't do proof of this statement. And as of today, the largest twin primes found is this one. It has a 388,342 decimal digits. And still the theorem is not true. So another beautiful is that you just take this example. 4 can be written as 2 plus 2. 6 can be written as 3 plus 3. 8 can be written as 3 plus 5, and so on. From this, what you can observe, every even number greater than 2 can be written as sum of 2 prime numbers. That is the statement you can get from this particular cases. And this statement is one of the best known unsolved problem in number 3. The statement is every even integer greater than 2 can be written as a sum of 2 primes. This is one of the best known unsolved problem in number theory. But people are verified up to 4 into 10 to the power of 8 to have taken all even numbers below 4 into 10 to the power of 18, and they have checked that the statement is correct. But after that, we don't. The proof must be, you have to prove this theorem more generally. Take n is any even integer greater than 2. You have to express that as a power of 2 prime. Very simple question. Very simple. Your non-mathematics background also, they can understand what is actually the whole conjecture. It is conjectured in, think about, in 1742 years ago. Now almost we are nearly to the 300 years. Still the theorem is not proved. But the statement looks like very simple. So take this one. Just similar to that, we just ask, this is a definition, a prime triplet is a set of 3 primes in which the smallest and largest differed by any triplet, P plus 6 or P plus 4, P plus 6 are all 3 are prime numbers, then you call it a prime triplet. And you can see some examples. These are all prime triplets: 5, 7, 11, 7, 11, 13, 11, 13, 17. They're all prime triplets. Now the same question, whether there are infinitely prime triplets or prime triplet conjecture. Still it is unsolved problem. And let us take this another one. Let us take n is equal to 1. Take 1 and between 1 and 4, you can find that 2 and 3 prime numbers are there. That is 1 plus 1 whole square. That is nothing but 4. Take 2 square is there. 2 plus 1 square will be 9. In between 4 and 9, there are 2 prime numbers. take 3 square, 3 plus 1, 4 square is 16. In between 9 and 16, there are two prime numbers. In general, you can ask this question. Is there always a prime between n square and n plus 1 square? Still, this problem is unsolved. We take another one. So there are at least 4 primes between squares of consecutive odd primes. So there are always at least 4 primes between squares of consecutive odd primes. This also open question. So what is the meaning of this? At least 4 primes between squares of consecutive odd primes. At least 4 primes. We take 1. What is the next odd number? 3. We take the square 1 and 9. In between 1 and 9, there are 4 primes. 2, 3, 5, 7. Like that. We take 3 and what is the next odd number? 5. What is 3 square? 9. 5 square is 25. In between 9 and 25, there are at least 4 primes. Very simple question. There exists at least, the question is that whether there is always at least, question is that, which says that at least 4 primes between square of consecutive odd primes. It's still an open problem. So another one is the same question you can ask for n square. This pair you can ask n square plus n plus 1 whole square. You can ask same question. Still it is open. This is, you know, that any number of type 2 to the power of n minus 1 is called Mersenne numbers. When 2 to the power of minus 1 is prime, it is called Mersenne. Named after Mersenne, early in 17th century. And these are the few examples. You see that. So the natural question is that here, these are the problems related to this Mersenne number still open. Are there infinitely many Mersenne primes? Are there infinitely many Mersenne primes? So these 4 questions still open. Still mathematicians are unable to give answer to these 4 questions. So there is another one, Fermat numbers. You may probably heard that Fermat numbers. The number of the type 2 to the power of 2 to the power of n plus 1, n greater than equal to 1, is called the Fermat number. And you can see that this is the Fermat number. Fermat prime is when this number is prime number, that is called a Fermat prime. You can see that F1, F2, F3, F4 are prime numbers, but F5 is not a prime. So these are the questions still open about the Fermat numbers. The question is that is Fn is composite for n greater than equal to 5? We don't know. After F6, up to F5, we know some information. Why we are targeting about the prime numbers? Because prime numbers are very important. They are the building blocks of number system. As fundamental theorem of arithmetic says that every integer greater than 1 can be written as a product of prime powers. Actually, these prime numbers are very important to the cryptography, security writing, hidden writings. So, all your, whatever the security, whatever your bank accounts and whatever ATM, how you can put some prime numbers. Still, we don't know the formula for generating all prime numbers. So let me take another one, Riemann zeta function. You know that Riemann zeta function is defined by zeta of s is equal to summation of 1 to of s. Real part of s is greater than. And if you see the zeros of this zeta function, minus all minus 2 minus is negative even numbers are zeros. They are called trivial zeros. Any other zero called a non-trivial zero. And all non-trivial zeros are lies in the critical string. The real part of S must be lies between 0 and 1. what this Riemann hypothesis is that all these non-trivial zeros have the real part 1 by So still now we don't have proof of this. And this, if anyone prove this one, they may get around the, to convert this dollar to the rupees, you may get it around the 9 point something crores if you solve this problem. Very simple. But very simple to understand actually, not simple problem. Very simple to understand, but you need a proof. You have to establish this by step. So each of these are just a few examples I have given in number 3. Like that, you may get it all the simple problems in all other areas to see that. And what tells these open problems? These open problems shows as the limit of current knowledge of mathematics. The existing knowledge of mathematics won't support to solve these kind of problems. You need the new things. So where mathematical research begins, to try to go behind these limits. So this is the next stage, is stage 5. This is just a given what is conjecture and how to do this. Just a few examples I have taken from my research area, number 2. And then stage 5 is after getting back to the stages of mathematical research. We're in stage 5. Stage 5 is proof development. This is the hardest and most time-consuming part of mathematical research. Because this is where most of your efforts will go, and where most of your setbacks will occur. But it is also where the deepest satisfaction comes from, because once you got proof, you will be very happy. So there are several standards for proving theorems. Every mathematician must know this. Direct proof builds the logical chain from hypothesis to the conclusion. Proof by contradiction. That means if you want to prove some statement, first assume that the statement is wrong. Then you will get, in between you will get a contradiction, therefore your assumption is wrong, therefore you can establish it that way. And one more is that very standard way is that mathematical indexing, that many already know that. First proof for first one place or then assume that is true for from n is equal to k, then you prove for n is equal to k plus k. This proof is very easy, but you need to find a pattern in that proof. If your research problems has this kind of pattern, then you can apply mathematical index. And proof by case-wise case. You divide your research problem into several cases and you attack each case separately. Most research tools uses combination of these techniques. So stage 6 and 9, that is what you believe you have a proof that work will. Once you have a proof, the work is not finished actually. The stage 6 is verification. So checking every step rigorously and reviewing your arguments carefully. And stage 7 is writing. You must present your arguments clearly and logically, and with proper citations to all previous work, following the conventions of your targeted. Just convert your paper to the journal format for which journal you are targeting, and you can submit. That is the stage 8 is preview. You submit to the appropriate journal and it will be evaluated by experts. They may ask for revisions, clarification, additional information. This is a normal and valuable part of the process. Respond to referee comments carefully and respectfully. And the stage 9 is dissemination. Presenting your work at conference, giving seminar talks, or posting to archive to share your paper before publishing to share in the archive. That is a very important. So that makes your work alive. And before submitting it to the journal, you should follow these rules as per UGC. As per UGC, you have to check similarity index. And you cannot nowadays you cannot do cut and paste. And that time is gone. In olden days, you just copy the introduction from somewhere, you can paste and you can do that work. But nowadays it's not possible because of this rule, plagiarism. So after writing research paper, before submitting it to the journal, first you have to check plagiarism, similarity. So you can use authenticate as or Turnitin approach to check similarity. According to the UCC rules, if the similarity is up to 10%, no penalty. Similarity is above 10% to 40%, so you will be asked to withdraw a manuscript. The similarity is above 40 to 60%, shall be asked to withdraw manuscript and shall be denied a right to one annual leave. So this is must you have to follow all this. Otherwise, you will face serious consequences. You can nowadays you see that if you submit research papers, they will check plagiarism. If your plagiarism, if similarity is more than 30% or even 20%, they will immediately reject your research article. Before that, first check your research article for similarity. If it is make sure that it is below 10%, and then you submit to the journal. Then you are also safe from these diseases. Otherwise, you will face consequences. You have to keep this point in mind. Okay, so mathematics. Now I come to the research approaches in mathematics. So mathematicians work in very different styles. You know that pure mathematicians and applied mathematicians, they won't work in a similar, they work in different. So there are several approaches in mathematics, like some are problem solvers. They focus intensively on specific, well-defined problem, and they will go narrow and deep about that problem, and they are going to solve it. The others are theory builders. They develop broad frameworks and structures that unify many result types. They create a new language for mathematics. Some researchers are primarily focusing on computational. They will try to find recognize the pattern, and they will find the conjecture, and they will allow others to solve the problem, or they are going to find the computer-assisted techniques and algorithms as in fourth color theories. And some are interdisciplinary, applying mathematics to other sciences like physics, biology, computer, chemistry, applied. And as for the methods, you see the methods. Major mathematical approaches includes these analytic methods, algebraic methods, geometric methods, combinatorial methods, computational methods, topological methods. And the most significant research problems requires not only one method. You need to know, you need to bring the ideas from all the methods. So, as you seen in the Fermat's last theorem, Andrews will prove that, but he connected many areas like modular problem, number theory, algebraic geometry connected, then he is able to do that concept. So my suggestion is that learn as broadly as you can. This is the one important thing that so today mathematics is become deeply collaborative. You already know that. You already seen that many research papers with more than 2 authors. We have seen that very 2 articles with single author. And also we have seen that papers, research paper with more than 10 authors. And 10 authors, one from India, one from USA, one from Africa, one from France, like that. How they manage to collaborate across the world? Those who are working collaboratively. The two lines Warleaf, math workflow, RQ, and video conference makes it easy to work together on different places. This Warleaf is a cloud-based. Just I will show few things here. It is very important. Just I will share after finally this in the end I will share this what is actually Warleaf, math workflow, and RQ. So not mentioned here. Next, just I will suggest these things. Everyone must know, must follow these things, and how researchers engage with mathematical researchers engage with mathematics. So through conference, seminars, workshop, online communities, social media, and archive, can be engaged with these things with mathematical community. So by attending conference, you can know the recent developments, and you can discuss with the speaker. And you can, by attending seminar work, you also know the same thing. And workshop, you can learn many things, and you can get contacts. All those things are very, very important. And this is very, very important. Everyone should know about this. For searching the literature, MathSci9 is the best. It lists virtually all mathematical research going back decades. And RQ is a preprint repository where researchers posting their research papers before sub-published. And from that you can know that what is the current development happening in your research. This is one of the very important things. And another one is that ZP Math, and this is another comprehensive database. And Google Scholar, you know that already many people already know Google Scholar useful for broad researches and citation tracking. And there is another one, Maths Workflow. This extra one is a remarkable platform for research level mathematical questions. And I will suggest these 4 groups, irrespective of research area, you better to read these because these will give more information. So, how to solve by George Polly and GHRD, a mathematician's apology. They are very good books. You can read them. And Cedric Villan, the birth of a team, and how to write mathematics. These are all very, very important. And finally, the open problems, you can see that all areas. You just Google it, open problems in number 2, you get a list of problems which are not solved. Just you get the open problems directly, and very difficult to solve them. It will take light. And there is another one as per number 3, if you want to consult problems in number 3, you can see that consult problems in number 3 by Richard. And also you can see these open problems in ACI. You can see that. So now let me come to the course of research context. Now I want to take few limits and what way you can find research. Because no matter how brilliant your ideas, research requires support, financial support. In India, the primary source of research funding comes from government agencies like DST, Department of Science and Technology, SAR. Now it is replaced by Anusandhan National Research Foundation, Council of Scientific and Industrial Research, CSIR, UGC, DRDO, DBT, and ICMR. This ICMR is primarily for social sciences, but I get here because if you want to connect mathematics social science, you get the funding from here also. I see. Here also. These agencies fund both basic and applied research through grants, fellowships, and travel grants also do. And the industry and the private sectors are also fund research, but with the different variables. They tend to support applied and translation research to shorter time and plan the outputs at different stages. They need outputs. Otherwise, at any time, they may stop funding. Better to apply for this government agency. So let me see what are the benefits. You know that the benefits are always, you already know that. So you can buy equipment, whatever you want, you can buy in that brand, you can buy equipment, and you can use those equipment, those funds for travel. If you can attend conference, you can climb your expenses. Career attractiveness. You know that whenever you apply for promotion, they will give certain points for projects. So conference fundings, okay, of course, you can climb registration fees and other extra things. So finance funding. And, other things like through these grants, in your network, you can develop your own network. You can travel wherever you want, you can go for the discussion about the research, you can do that with grants. Let me come to the specific skills available for researchers in India. From BST, the startup research grant is there. This will be given to the teachers who are in the initial stage. When they got a job, they can apply within 2 years or within 1 year, they can apply for this startup research. The other one is that the fast track scheme is especially for any scientists, physics. And the prestigious Ramanujan Fellowship is there. This is designed to attract Indian scientists working in Africa to return and build their career here in India. BLC also has a dedicated scheme for women's researcher also there. So the women scientists, there are two schemes are there, scheme A and scheme B. Scheme A and scheme B. Opportunities for in scheme A, opportunities for women scientists and technologists aged between 27 and 57 who had a career break and wish to return to the active list. There is another scheme B and C for your Philippines are there. You can see that women scientist scheme B, internship for self-employment, Indo-US fellowship for women in state. You can search for all these things. Here you can find research. And this is a SERB. In SERB also provide many research skills. One is the matrix. It is applicable only for mathematics and theoretical mathematics. You can climb international travel also in this matrix. Another is that TARE, Teacher Associateship for Research Excellency. So facilities mobility for faculty from state universities, colleges, and private institutions to do research at IITs, IISc, IISAs, NITs, CSIR, ICAR, SMR, and central universities. And those who are working in state and colleges, you can apply for this and you can go and visit the IITs and you can work with the faculties of these private institutions. Because you know that you don't have any infrastructure available at the college. In that case, you just contact the professor who is doing similar research work as you are doing. Just contact the email and you can apply to this and you can go and work. There are other extra awards or research funding is there, early career research award is there, and There are fellowships. So this is for fellowships and project also they will grant you. National postdoctoral fellowship is there. Serve overseas postdoc. Those who are completed PhD, they want to do postdoc. They want to do postdoc. They can apply national postdoctoral fellowship and serve overseas postdoctoral fellowship. And if suppose you are applied, you want to go to attend a conference in abroad, your paper has been accepted, and in that case you can apply serve international travel. They will provide the registration fees and they will provide the airfare. They will provide to and to airfare. Now that after completion fees, you can apply for inspire statistics. This is very this is the salary will be around 1 lakh here, and you will be given 6 lakhs for procuring equipments, whatever you need. Promoting opportunities for women in that, so you have serve over fellowship education for women's researchers in regular service. Those who are regular service, they can apply for this fellowship. Serve over research. There are two categories there. So category 1 for state universities and colleges and private academic funding, they will do up to 30 lakh funding for 3 years. So the category 2 is women scientists from IITs, ISRs, IIC, NITs, and central universities. They will, and other laboratories, they will fund up to 60 lakhs for 3 years. You just see that where you are going to keep these skills. Right. And this is for international postdoctoral fellowship. Those who want to do postdoctoral outside, they can see directly all those things. Where you can get fellowship. And other national funding sources like MHRD fellowship, Commonwealth fellowship scholarships are going. DRDO, Defense Research and Development Organization is giving funding. NGC is giving funding for college teachers. National Board of Higher Mathematics is giving travel grant and also it will give funding for your research. Research grants are given by the CSIR and these are only a few things I have mentioned here. There are many things here. They are being funding for the research. The funding will be, if you are in the early stage, then one kind of fund will be there. If you are in the mid-career, you get one kind of fund will be there. If you are a senior researcher, you get one kind of research funding. It will be organized with 3 types. One is early career, mid-career, and senior research. And one more thing I would like to say here is that just as a mathematics, just I will start sharing. Just I will share my screen so that you can use some tools. Tools are very important. Just I will share my screen here. You see that? Can you see that? Can you see that? Yeah, this is ArcSy, where people are posting their research area before the publication. So if you just type ArcSy in the internet, you will get like that. And if you see that, you see the mathematics. You just see your research area. See that your research area, which is your research area. You just click that one. If you see number 3, see that the recent articles which are not published, they are submitted to the journal. You can get it. Those things is here direct. See, and when today they submitted how many research papers they submitted today? You see that See, this paper is submitted today. But this paper, see, when you submit this paper to the journal, it will take 1 year or 6 months or depending on the reviewing process. But through this platform, you get this research paper. Just click PDF and you can get the recent article. Today they submitted. But this paper is not published. And you can see that by reading this, you can get to know that what is the things happening in advance. You can know that what is currently happening in your research. See, today, this paper is submitted today. And it is submitted on this also today only they submitted to the archive. And you can know that well in advance. This paper may come to the journal after 1 year. We don't know how many months it will take. But through this platform, you can get that paper directly. Another one is that you see, you can take classical analysis and reviews. You just click it, you will get the recent articles. Analysis of PD. This is the analysis of PD, partial differential equation. See, today only they submitted many papers. There are many papers are available to see. So from this platform, you can know that you can learn what is currently happening in your research currently. And if you just click this paper, and if you go to the conclusion section, it has a conclusion section, they may define some research problems. We see that concluding. They're telling something they are unable to do, and what the restriction of the results, and what feature has to be done. You can see that these are the direct research problems, direct invitation to you people to solve this kind of problems. Direct. If you know the basic perspective, you know the research area very well. You have to know everything. That is the one thing. This is the other thing. You see that there are many all group theory. If you want group theory, you see that today only they submitted many research papers. Or you can type mathematics. You need just type mathematics and you search it. You can type your keyword. Suppose you want to need a research papers in theory of quantics. This is the recent paper published is submitted on 9th March. So one problem. Another is that math overflow. This is the one more. And here you can get research problems directly. See the unanswered problems. There are 51,000 questions with no answers. Nothing. Now you can find your area of interest and you can get the problem, research problems directly. There are 51,000 questions are unsolved. You have no solution. So if you see the newest one, you see that. So like that, you can get research problems from your research area directly to it. So this is the math is actually online platform where mathematicians are working on the recent mathematical questions, research questions, and they are discussing the ideas. Another one is that this is very, very useful to the mathematics community. This is called overview. It's a cloud-based online software. This is where you can, so many, most of them are writing your research articles in LaTeX. Hmm. So you can create your, if you want to do a collaboration one, you just create a project name, such as research. Create a researcher, and then we have created a research file. You just type whatever you know the things, whatever you got the research, whatever the results you feel, you just type it. And if you are doing collaboration work, then you can share this to your collaborator. Just type here and invite them. And once they join, then whatever you are typing here, they will see directly in their office. And they will also do, they will also continue that. That's how you can engage in the collaboration. Whatever you are typing today here, I suppose you are typing, I got this result, this is the proof. Now your collaborator can read your proof and you can correct your proof. And you may add new things to that. This is somewhat useful for you to take this. These are the things I wanted to tell you. To come to my reason. So with all these things, I will stop. Good luck for your research journey. So this is purely I concentrate on only theoretical way for mathematics. So any questions, please ask. I can yeah, yes. So thanks for giving this